Hi guys, here are your video notes for types of chemical bonding. Before we start, just a little note. Please go ahead and take notes. So, as you know, we're not coming back to school. You will be taking your tests online and at home. And just like in class, you're going to be able to use paper notes only on the test. So make sure you take notes in some way, shape, or form. To make it easier for you, I've written down our key phrases in blue. So I highly recommend anything on this presentation that is in blue to pause and write that down because that's key information. You're welcome to write the other stuff down, but I think that's the bare minimum that you should be doing. So go ahead, grab a notebook, grab a pencil, let's get started. So this is a bit of a review, but the real question that we're kind of asking is, why do atoms bond together? So we know that chemical bonding is an attraction between atoms so that they stick together and they form molecules. The reason that elements bond is so that they can reach stability. And we know from past lessons that an atom is stable when it has 8 valence electrons. So there are 2 ways to satisfy the octet rule, or to get stability with 8 valence electrons. Number 1, an atom can share its valence electrons with another atom. We call this covalent bonding. Number 2, an atom can transfer electrons from another atom or to another atom to get 8 valence electrons, and we call that ionic bonding. So if we look at this lithium atom up here, lithium only has 1 valence electron. So it wants to reach stability by having 8. Lithium has 2 options. It can share its valence electrons, or it can donate its valence electron, depending. And we'll find out which lithium is likely to do later on in this presentation. So let's talk about covalent bonding first. Covalent bonding occurs when electrons are shared between 2 or more atoms. Let's break this word down a little bit. So co. The prefix co means joint or to share. For example, a co-teacher or co-stars. Co-stars share the limelight. So co means to share. Valent is just from the word valence, which we know are outer electrons. So the word covalent means to share outer electrons. Hopefully that makes it a little bit easier to remember. And an example of a covalent bond is water. So we have a picture of this water molecule right over here. Our water molecule, our oxygen. So our oxygen has 6 valence electrons, highlighted in red. And each of these hydrogen atoms has 1 valence electron here in white. So in a water molecule, our 2 hydrogen atoms are going to share their valence electrons with oxygen. So now oxygen has 6 of its original valence electrons in red, plus 2 shared ones from each hydrogen atom. So now oxygen has a total of 8 valence electrons. It's sharing with hydrogen, so it's bonded to them, and everyone is happy and stable. Let's talk about ionic bonding now. So what is an ionic bond? An ionic bond occurs when electrons are transferred from one atom to another. And transferring or moving an electron from one atom to another is going to create an attraction between these 2 atoms. Let's take a classic famous example. We have sodium and chlorine. Sodium only has 1 valence electron. Chlorine has 7 valence electrons. Neither of these guys are very happy or stable because they do not have 8 valence electrons. Keep in mind here that electrons are negatively charged. So to form an ionic bond, our sodium atom is going to donate its 1 valence electron to chlorine. So because our electrons are negatively charged and chlorine just got an extra electron, chlorine is going to have an overall negative charge now because it got an extra negative charge from the donation of this electron. Meanwhile, sodium lost a negative electron. So sodium is going to have an overall positive charge, right? If you lose something that's negative, you're going to have more positive. So if something gains an electron, it's going to have a negative charge. If it loses an electron, it's going to have a positive charge. So now sodium is overall positive, chlorine is overall negative, and those two atoms are going to be attracted to each other because positives and negatives attract, right? Opposites attract. And so that is what forms the bond between these two atoms. Fun little comic for you guys to just reiterate something that's important to remember. If an atom loses an electron, it's going to be positively charged, and vice versa. If it gains electrons, it will be negatively charged. So what is an ion? We have these ionic bonds, and ions play a really big part in them. So an ion is what we've just been talking about. It's an atom or a molecule with an electric charge that results from it gaining or losing electrons. So let's look at an example. We have a picture of a lithium ion down here. I'm sorry, this is not a lithium ion, it's a lithium atom. So we have this lithium atom down here. It has 3 protons in the nucleus, which are in red, and 3 electrons, which are in black. This atom of lithium right here is neutral, which means it has no charge because it has the same amount of positive protons as negative electrons. If we lose one of these electrons in lithium, our molecule is going to turn into this one over here. So this lithium ion, now it's an ion, has 3 protons and 2 electrons. It has more positive protons over here than it has negative electrons. So that means that this is a positively charged ion. So the big thing to keep in mind here is that neutral atoms with the same amount of protons and neutrons can become ions by gaining or losing electrons. If a neutral atom loses a negative electron, it becomes a positive cation. If a neutral atom gains negative electrons, it becomes a negative anion. So both of these are ions. We just give them different names. If it's positive, we call it a cation. Negative, we call it an anion. So essentially, ions occur when the protons do not equal the electrons. If you have a positive ion, it's called a cation. And a way to remember this is that cats have paws. If it's a negative ion, it is called an anion. So how are cations and anions formed? how do we know which elements are going to make cations or positive ions and which will make anions or negative ions? Well, metals are usually going to form positive cations. And this is because our metals, as we know, they tend to lose electrons, right? So if this is a metal, it's going to tend to lose an electron. We know that they hold on to electrons very loosely, and that's also why they are great conductors of electricity. Nonmetals, on the other hand, are going to form anions. We know that nonmetals hold tightly to their electrons. So they are going to gain valence electrons because they don't want to give them up. Because our nonmetals hold on to their electrons, they do not conduct electricity and they form anions or negatively charged ions from gaining electrons. Quick knowledge check. So go ahead and answer the question to the best of your ability using this image to guide you. Will bromine become a cation or an anion? Take a second. So hopefully you looked at your periodic table and you saw that bromine is over here. It is in blue, so it is a nonmetal. We know that nonmetals hold on to their electrons tightly. So bromine is not going to give up electrons, it's going to take electrons. So because it will receive negative electrons, it's going to be an anion. Last thing, so when do our different types of bonding occur? We, depending on an element's identity, can actually predict what type of bond will happen. So covalent bonding occurs between nonmetals. So two nonmetals bond together with covalent bonding. And that's because two nonmetals are both going to hold on to electrons tightly. Nobody wants to give up their electrons, so they have to share. An example of this is CO2 or carbon dioxide. We have carbon over here, oxygen over here. We see that they're both blue nonmetals, so they are going to share electrons because they both hold tightly to electrons. On the other hand, ionic bonding is going to occur between a metal and a nonmetal. So the metal in this pair is going to donate an electron to the nonmetal, right? Metals give up electrons freely, they don't really care, while nonmetals are going to kind of be greedy for those electrons. An example of this is potassium iodide. Fun fact, this is a salt that can actually help your body stop absorbing radiation. So we've got potassium over here in red, it's a metal. Iodine over here in blue, it's a nonmetal. A metal plus a nonmetal is an ionic bond. Last knowledge check. So what type of bond will occur between lithium and sulfur? Take a second. So hopefully you looked at your periodic table, you said, lithium is a metal and sulfur is a nonmetal. When we have a metal plus a nonmetal, that is an ionic bond. That's it. That's all for this section, folks. Hopefully you took good notes that you're going to be able to use on the test. The last part of this assignment is to complete a few short questions so that I know you looked at the material. This is called 5.1 Types of Chemical Bonding. Go ahead and complete that and submit in Canvas. Thank you very much. I hope you guys are doing well, and I'll see you next time.